Hello everyone, Standard 10, Math subject, chapter number 2, Polynomials, part 5. In previous video, we have seen a mental theorem. Okay. Now, we move towards to the factorization of polynomial. Okay. Factorization is nothing but if that number is completely divided with my dividend. Okay. So if I take 6 and 33, okay, now I am just dividing my 33 by 6. So what I am getting is 30. It leaves the remainder 5. It left the remainder 5. Okay, so we can say that 6 is not completely divided by 33. Okay, so the 6 is not a factor of 33. Okay. Now, if I take 30 and divide with the 6, I am getting 30 and remainder 0. It means when my remainder I am getting 0, it means this number is completely divided my dividend. So we can say that 6 is a factor of 30. 6 is my factor of 30. We can write this one. 30 equals to 6 into 5 plus remainder 0. Okay. So, if I am getting remainder 0, it means this number is completely divided my dividend. It means 6 is a factor of 30. 6 is a factor of 30 when I am getting my remainder 0. Similarly, if we talk about a polynomial, if p of x is a polynomial of degree greater than and equal to 1 and a is any real number, then x minus a is a factor of p of x if p of x equals to 0. So, by remainder theorem, p of x equals to, we know that how to write the factors x minus a form. Okay, so the x minus a q of x plus p of a. Okay, p of a. This is nothing but my remainder theorem. Okay. X minus a is a factor of p of x if my remainder is 0. Okay. If my remainder is 0, then we can directly say that this is the factor of p of x. Exactly similar to this one. I am dividing 30 by 6. I am getting my remainder 0 over here. So we can say that this 6 is a factor of 30. This 6 is a factor of 30. So exactly similar to this one. X minus a is a factor of my p of x if my remainder p of a is 0. Okay, now the second thing is p of a equals to 0 if x minus a is a factor of p of a. Okay. If my x minus a is a factor of p of x, we can say that this is my remainder is equals to 0. It's just a vice versa thing. Okay. If my remainder is 0, I am getting x minus a is my factor. If x minus a is one of the factor of p of x, then we are getting my remainder 0. Why I am getting my remainder 0? Because we know that if x minus a is a factor, then we can write this way. a factor of p of x. So we just replace x equals to a. So I'm getting p of a here. So I'm replacing this x with a. So I'm getting over here a minus a, q of a, q of a. Okay, so this one is equals to 0. So my what I'm getting over here, p of a equals to 0. My remainder I'm getting over 0. So if my remainder is 0, then x minus a is also is factor of p of x. If x minus a is a factor, then p of a is always equals to 0. That is the remainder theorem tried to say. Okay, now we move towards to some questions. Examine whether x plus 2 is factor of x cube plus 3x square plus 5x plus 6 and of 2x plus 4. Okay, we have to examine that x plus 2 is a factor of this polynomial and this polynomial. Okay, so the given thing is if x minus a is a factor of p of x, it means the factors were given. So we directly just write in its 0 form. Okay, so whether x minus is a factor of this polynomial, so I'm just giving the name of this polynomial, so it's easy for us. So p of x is x cube plus 3x square plus 5x plus 6, and let's say g of x some another 2x plus 4. Okay, now x plus 2 is a factor, so 0 of x plus 2 is minus 2 because we have to examine, okay, whether this one is the factor or not. So we can write in a 0 form. So I'm getting x equals to 2. So therefore it's nothing but likewise x plus 2 equals to 0 and x equals to I'm getting minus 2. We just have to find the value of x. Okay, so I'm getting x equals to minus 2 over here. Now replace this x equals to minus 2 in both the equation. Okay, vice versa. If I'm replace my x with a, I'm getting my remainder 0. If I'm getting my remainder 0, then we can say that x plus 2 is a factor of p of x and g of x. Now put x equals to minus 2 in p of x and g of x. Okay, so the p of minus 2, I'm replacing minus 2. So minus 8 plus 4 3 12 minus 10 plus 6. Okay. Now, what over here is, I'm getting plus 10, minus 10 and plus 6. What left is plus 6. Okay. Now, plus 6, no, plus 6. Plus b. getting 0. Okay, now P of G of minus 2. G of minus 2. So the minus 4 plus 4 equals to 0. So when I replace my x with minus 2, I am getting my both equation equals to 0. It means x plus 2 is a factor of, therefore x plus 2 is factor of p of x and g of x. Okay, likewise we can solve nothing. If we want to examine whether the given polynomial is a factor of other remaining polynomial or not, we just simply find it 0. It means we just find the value of x first, x, and whatever the value I am getting x equals to, I am putting that value in my equation. After putting that value in that equation, whether I am getting 0, that means that number is factor of my given polynomial. If I am not getting 0, it means it's not a factor of that polynomial. Okay. Now the next question. Next question says, find the value of k. We have to find the value of k. If x minus 1 is factor, x minus 1 is factor of 4x cubed plus 3x square minus 4x plus k. Okay. If x minus 1 is a factor of this polynomial, so first see the factors of this polynomial, it means we just write in it 0 form. Okay. So therefore x minus 1, 0 of x minus 1 is equals to plus 1. How we getting the plus 1? Be careful with the sign. Okay. So here x minus 1 equals to 0. So x equals to 1 I am getting. X equals to 1 I am getting. So it's nothing but the value of x is plus 1. Okay. Now if this is the factor, it means if this is the factor, then we know that we have seen that in a factorization theorem, my p of a equals to 0. If x minus a is a factor of p of x, then we getting is my remainder is p of a equals to 0. So therefore p of x equals to what is it over here? X cubed plus 3x square minus 4x plus k. Okay. If x minus 1 is factor of p of x, then my p of 1 equals to 0. P of 1 equals to 0. So now replace this x equals to 1 in this equation. Okay. So now p of a is bigger than this one. So the 4 1 cube plus 3 1 square minus 4 1 plus k equals to 0. K equals to 0. So I am getting 4 plus 3 minus 4 plus k equals to 0. Get cancel. So I am getting k plus 3 equals to 0. So the k equals to minus 3. The value of k is minus 3. Okay. Now we see the next question. let's understand one thing. By splitting middle term. By splitting middle term. See, here my factors were given. We just directly put the value and check whether that polynomial is a factor of a given polynomial or not. Okay. If and one of this and the second method is for a quadratic polynomial is splitting the middle term. For example, if my polynomial is x square plus x plus 2x plus 1. Okay. If my polynomial is x square plus 2x plus 1. Okay. So the splitting you look at our splitting the middle term. Okay. First, we have to write our polynomial in a standard form. Standard form is nothing but we write my polynomial in a descending order. Okay. If the polynomials were given like 2x plus x square plus 1, the first we have to write in a standard form. Standard form is nothing but write in a descending order. Okay, we have to write in a descending order. Okay, after writing the descending order, you can find my 2x is the middle term. Here my x square is not a middle term. That's why we have to first write in a standard form. Okay, so here my 2x is a middle term. We have to split a middle term. Okay, so to the splitting a middle term, first we have to take a product of my first term and a third term. Okay, so if we take the product of this one, here is nothing but 1 is always there. So 1 into 1 is 1 only. Okay, so the product of my first term is x square into 1, which is x square. Okay, now my x square I am getting product, so we have to take such value over here that my product I am getting my product is x square plus 1 and whose sum is my middle term. Okay, so whose sum is my middle term. So we have to factorize this one. So x square I am factorizing x into x. Okay, so this is one of the factor is x into x. Okay, if I'm adding x plus x, what I am getting? My middle term only. This is nothing but a splitting of middle term. So I am writing x square and I am taking x plus 1. Okay, this is nothing but a splitting a middle term. We have to take such factors of the product of my first term and last term. Okay, we have to take such numbers or such polynomials such that whose sum is exactly equal to my middle term. Okay, now just grouping. Okay, now take out the common part. So x is common. So what left over here is x plus 1. Plus 1, nothing is given, then 1 is always there. 1 is common in thing. So what left is x plus 1 only. Okay, now it's my first term and second term. What is the common thing? X plus 1 is common. So we just take out that part. What left over here is x plus 1. So the factors, now by splitting the middle term, I am getting 1. Okay, so here is, see, we know that in a quadratic polynomial there can be at most 2 zeros. So my zeros I am getting x plus 1, x plus 1. So now we have to check whether these are the factors of this one or not. Okay. So first we just take the zeros. X plus 1 equals to 0. X equals to minus 1. Now replace this x equals to minus 1 in this equation. So p of minus 1 equals to, I am getting plus 1 minus 2 plus 1 I am getting 0. Yes, this is the factor of this polynomial. Okay. Likewise, we have to solve the questions. Now we move towards to some questions. The question number 3. Factorize 6x square plus 17x plus 5 by splitting middle term. By splitting middle term. Now, so 6x square plus 17x plus 5. Okay, we have to split 17. Okay, my first step, what is my first step? We have to take a product of my first term and last term. Okay, so the 6x square into 5x, it's nothing but 30x square. Now forget this x square. Okay, forget this x square. Now 30. Now take the factors of 30. So what are the factors? 5 and 6 already. 5 and 6 both are the factors only. But we have to take such factors whose sum is equal to my middle term. If I am sum this one, what I am getting is 11, which is not equals to 17. We want such factors of 30 whose sum is equals to 17. Okay, try another one. 15 into the, yes, the another one is 15 and 2. 15 and 2. Okay, now sum this one. I am getting 17. Yes, I am getting 17. So we are going to take these factors of 30. Okay, we are not taking this one because when I sum this one, I am getting is 11, not 17. We want my middle term as it is. Okay, so the factors of 30 we are taking is 15 and 20. 15 and 2. So the 15x plus 2x I am getting 17x. Okay, when I multiply this to 1, 15x into 2x, what I am getting? 30x square. Okay, I am getting my actual product. Yes. So we are writing 6x square plus 15x plus 2x plus 5 plus 5. So now just grouping. What is the common thing over here? Maybe 3x. 3x. What left is x plus 5. Now what is the common over here? 2x. 1. 2x plus 5. Okay. Now these are my two terms. What is the common part? 2x plus 5. So I am taking it out. 2x plus 5. So what left is 3x plus 1 and left. Okay. So this is the factors of my 6x square plus 17x plus 5. Okay. By splitting the middle term. Okay. You have to factorize this polynomial by splitting its middle term. Okay, so the answer we getting is 2 2x plus 5 and 3x plus 1. Okay. Now we move towards to another question. Another question. Question number 4. Factorize x cube 3x square minus 9x minus 5. Okay, we have to factorize this cubic polynomial. Okay, we can, by splitting the middle term we cannot do. It is only possible in a quadratic polynomial. Here given is my cubic polynomial. So we cannot take this one directly. Okay, we have to factorize this whole term. Okay, so the method I'm using is a trial and error method. Okay, hit and trial also we can call, or trial and error method. Okay, so let me do this part first. See, in the trial and error method, we just take some numbers and those numbers we put into my polynomial. Okay, after putting that number, if I am getting 0, it means that number is my factor of this polynomial. Okay, so it is quite lengthy. How many numbers you will take? Okay, there are infinitely many numbers. So the logic says, let's just write first one. P of x equals to x cube minus 3x square minus 9x minus 5. Okay. Now the first step. Okay. First step says, take a prime factor of my constant term. What is my constant term over here is 5. Take a prime factorization of constant term. So take prime factors of constant term. Okay, take a prime factors of a constant term. So now prime factors of 5 are, okay, so the prime factorization of constant term, 5's factor is 5 is my prime number. It can be 1 or that number only. Okay, so we are, okay, so which number we have to take? Either 5 or either 1. Okay, there are 4 possibilities can be occurs. For a 5 plus 5 or minus 5. For a 1 plus 1 minus 1. Okay, so the prime factorization of 5 are plus 5 minus 5 plus 1 minus 1. Okay, so now what next step is, we are taking only these 4 numbers and put into my equation. Okay, we are just taking this 4 number only. Okay, now minus 3, minus 9, minus 5. Okay. Now, so I'm getting over here is 9 minus 40, minus 17, plus minus 16, which is not equal to 0. It means plus 1 is not factor. Okay. Now, let's check with minus 1. Let's check with the minus 1. I'm getting minus 1. Okay. Minus 3, plus 9, minus 5. Okay, so plus 4, plus 4 and minus 4. I'm getting 0. Okay, so we stop over here. We just find only 1 0. Okay, now we are not checking for the this 2 1. Okay, now this is my cubic polynomial. So we know that there are at most 3 zeros. There are at most 3 zeros. Now we getting my 1 0 is x equals to minus 1. Okay. Therefore, x equals to minus 1. Here I replace my x with minus 1. So x equals to minus 1. Okay. Is, instead of writing x equals to minus 1, therefore x plus 1 is factor of p of x, is a factor of p of x if here is I'm taking x minus 1. So we have to write x plus 1 because it's nothing but x equals to minus 1. So I'm taking this minus 1 into this side. So I'm getting x plus 1. Okay. So the x plus 1 is the factor of p of x. Okay. Now division algorithm. Division algorithm says is dividend equals to divisor into my quotient into remainder. Okay, so my dividend is, what is my dividend? Dividend is x cube minus 3x square minus 9x minus 5. Okay, so what could be my divisor? One of the factor is this one. It means this is my divisor. So x plus 1 into q into r. Okay, so see, this is nothing but a factor we found over here. It means my remainder is equals to 0. My remainder is equals to 0. Why? Why 0? Why 0? Because x plus 1 is nothing but a factors only. Factor only. Okay. Now we just find our cube. Okay, we just want to find our cube. So what I am getting over here is x cube minus 3x square minus 9x minus 5 divide with x plus 1. Okay, if I am dividing this polynomial with x plus 1, I am getting my quotient. Okay, getting my quotient. Okay, just divide this one. Just dividing this one. X cube minus 3x square minus 9x minus 5 x plus 1. Okay, so how to divide this one you know already learned. So x square x cube plus x square. So the minus get cancelled, minus 4x square minus 9x minus 5. Okay. So what left is minus 4x. Okay. So minus 4x square minus 4x plus this one gets cancelled. Again I am getting over here is minus 5x minus 5x. Okay. So let's divide this one. I am getting getting plus 5. So minus 5x minus 5 plus I'm getting my remainder 0. So this is my quotient. So what left over here is quotient is x square minus 4x minus 5. Okay, this is my quotient. This is my quotient. If I'm multiplying with this one over here, so I'm getting x plus 1 equals to my p of x. Okay, p of x is this one. Okay, now we can do our splitting the middle term. Yes, we can do. So x square into minus 5. Okay, so I'm getting minus 5x square. Okay, now we have to just factorize this one. 5 and 1. This is the only one factor. Okay, now we want the sum is minus 4. The sum is minus 4. It means, look at over here. If here a plus sign were given, it means we have to sum this product. If negative sign is given, it means we have to subtract this product. Okay, so here we want is a 4. Okay, if I am taking minus 5 minus 1, I am getting minus 6. So it means if I take minus 5 and plus 1, I am getting minus 4. Okay, so this way we can split. So x square minus 5x plus x minus 5, x plus 1 p of x. Okay. Now what is common? X minus 5 plus 1, x minus 5, x plus 1 equals to p of x. Okay. Now x plus 1, x minus 5, x plus 1, p of x. See, we know that cubic polynomial there are three zeros. So I am getting 3 factors. I am getting x plus 1, x minus 5, x plus 1 are the factors of my cubic polynomial. So what is the process to find the factors of cubic polynomial? First thing, we do trial and error method. It means we put different numbers and check whether that number is a factor of my polynomial or not. So it is quite lengthy. Instead of taking all the numbers, we just take a constant number, okay, and factorize this one. Okay, so my factor of 5 is 1 and 5 only. Okay, so for a 1 there are 2 possibilities. Either it can be plus 1 or minus 1. For a 5 there are again 2 possibilities, plus 5, minus 5. So we just take all those factors. It means we just put all these numbers into my polynomial. If I am getting equals to 0, it means that only number, that number is a factor of this one. So the second thing is, we just take this factor and divide with this one. We just take this factor and divide with this one and finding my quotient. Okay, so after dividing x plus 1, I am getting this quotient. Now we can do our splitting the middle term. Now use the splitting the middle term and factorizing and get your 3 zeros of this polynomial, 3 factors of a cubic polynomial. Okay, now